We will discuss some numericals related to relationship between the number of spheres and voids. Okay. See first question number 1. An ionic compound has HCP lattice. The cation P occupies half of the tetrahedral void and the anion Q occupies the lattice site. What is the formula of the ionic solid? So, using the relationship between the number of spheres and number of voids, that is either tetrahedral or octahedral, we are going to solve this problem. So, first thing you have to identify the lattice, which ion is occupying the lattice. Okay. See, an ionic compound has HCP lattice. The cation P occupies half of the tetrahedral void. So, the cation is occupying the tetrahedral void and the anion occupies the lattice site. So, which is occupying the lattice site, that is considered to be the sphere. So, this thing you have to do first is you have to identify the cation and anion given and which ion is occupying the lattice site, and which occupies the lattice site, that is considered as the sphere. So, here which is occupying the lattice site, the anion Q is occupying the lattice site. So, the anion will consider it as the sphere. Then what is the relationship between number of spheres and tetrahedral void? Why tetrahedral void? Because here the cation is occupying what? The tetrahedral void. So, already we have discussed number of spheres is equal to twice tetrahedral void, that is n spheres is equal to 2n tetrahedral void. So, you can solve it in different ways. See, the way I am going to apply is that, so Q is the sphere here because it is occupying the lattice site. So, I am just going to write number of Q ions is equal to 1 I am going to take. With this I am going to correlate. Okay. So, the spheres here is equal to how much? 1. So, what will be the number of tetrahedral voids? 2. So, the P occupies what? The half of the tetrahedral voids. So, number of P ions is equal to what? What is the relationship? 1 sphere, 2 tetrahedral voids. So, 2 and how much is occupied? Only half. So, it is how much? 1. So, what is the number of Q ions? 1. Number of P ions is also equal to what? 1. So, what will be the formula? The formula is PQ. Is it clear? Once more I will explain. See, an ionic compound has HCP lattice. The cation P occupies half of the tetrahedral void and the anion Q occupies the lattice site. What is the formula of the ionic solid? So, first you have to identify is which is occupying the lattice site. That is considered to be the sphere. Here the anion is occupying the lattice site. So, and the anion is what? Q. So, we will consider it as the sphere, and the cation is occupying what? The tetrahedral void, that is P is occupying the tetrahedral void, and you know the relationship n sphere is equal to 2n tetrahedral void. So, I am just going to consider, I am going to correlate it with 1 sphere. So, number of Q ions I am going to take it as 100. So, what will be the number of tetrahedral voids? 2. So, number of P ions is equal to 2 into half, that is 1, because why? Half of the tetrahedral void is occupied. So, the formula is what? PQ. Or if you want, you can do it in another way also. Number of Q ions, let us take it as what? N. Then what will be number of P ions? Because it is occupying tetrahedral voids. So, it is 2n. So, I will write it as what? 2n, and how much is occupied? Half. So, again it comes what? N. So, what will be the formula? Pn Qn, which is equal to what? PQ. So, any way you can do it, whatever way you do it, you will be getting what? The same relationship. Or you can take number of Q ions is equal to 100. So, number of P ions will be what? 200. So, again it comes to be what? 100. So, the formula will be what? P100 Q100. Again it is equal to what? PQ. Is it clear? Now, the next question is, see, ferric oxide crystallizes in HCP array of oxide ion with 2 out of every 3 octahedral void occupied by ferric ions. What is the formula of the oxide ion? Now, which is occupying the lattice? Ferric oxide crystallizes in HCP array of oxide ion means the oxide ion is occupying the lattice. So, number of oxide ion, we will take it as equal to how much? 1. Then what is given? With 2 out of every 3 octahedral void occupied by ferric ions. With 2 out of every 3 octahedral void occupied by ferric ions means how much of octahedral void is occupied? 2/3. 2 out of every 3 octahedral void is occupied by ferric ions. So, 2/3 of the octahedral void is occupied by what? Ferric ions. And what is the relationship between the number of spheres and octahedral voids? N spheres is equal to n octahedral voids. N spheres is equal to n octahedral voids. So, what will be the number of ferric ions? So, number of ferric ions is equal to 1 into 2 by 3. Why 1 into 2 by 3? Because there is one oxide ion we have taken. So, the number of octahedral void is also how much? 1. And how much is occupied? 2 out of 3. So, it is 2 by 3. So, it will be 2 by 3. So, what will be the formula? Fe 2 by 3 O, or it will be what? Fe2 O3. Is it clear? So, this is the next question. So, it is very simple, or if you want to do it, this also you can do it. Number of O2 minus ion, you are going to take it as what? N. Then what will be the number of Fe3 plus ion? Again N into 2 by 3. So, you will get 2 by 3 N. So, what will be the formula? Fe 2 by 3 N O N, or it will be equal to what? Fe 2O3. So, any way you do, you will get it the same way. Only thing you have to remember is the relationship between the spheres and the voids. N spheres is equal to 2 tetrahedral voids, and N spheres is equal to how much octahedral voids? Same, N octahedral. Next question is, in a solid, oxide ions are arranged in CCP lattice. 1/6 of the tetrahedral voids are occupied by cation and 1/3 of the octahedral voids are occupied by cation B. What is the formula of the ionic solid? So, 2 cations are there, A and B. A is occupying 1/3 of the octahedral void, sorry, 1/6 of the tetrahedral void is occupied by A and 1/3 is occupied by B. So, which is occupying the lattice? The oxide ion. So, number of oxide ions is equal to 1. Then A is occupying tetrahedral voids. So, N sphere equal to 2N tetrahedral void. So, number of A ion, because it is a cation, will be equal to how much? 2 into 1 by 6, it will become 1 by 3, because how much is occupied? 1/6 is occupied. Then N sphere equal to how much octahedral void? N octahedral void, and number of B ion is equal to how much? How much it is occupying? 1/3. So, 1 into 1 by 3, that is 1 by 3. So, what will be the formula? A 1 by 3, B 1 by 3 O, or AB O3. So, this is the formula. So, hope you have understood it, how to find out the formula using the relationship between spheres and void. Next, we will discuss about calculations involving unit cell dimension. Okay. Calculations involving unit cell dimension. See here, the edge length we can find out using X-ray diffraction. Now, if you know the type of lattice, we can find out the number of atoms per unit cell. So, if you know the edge length, you know number of atoms per unit cell and molar mass or atomic mass of the given substance, then you can calculate what? The density. So, how will you calculate the density of the unit cell? Okay. And let us consider a unit cell. This is a unit cell which is having particles. It can be simple cubic, body centered cubic, or FCC. And we know the edge length is A. So, let the edge length of the unit cell equal to A centimeter. So, what will be the volume of the unit cell? Volume of the unit cell equal to A cube centimeter cube. Okay. Then density of unit cell is equal to mass of the unit cell divided by volume of the unit cell. Now, how will you find out the mass of the unit cell? Mass of the unit cell is equal to number of atoms per unit cell into mass of each atom, mass of each atom. So, that I am going to write it as Z into small m. Okay. Now, how will you calculate mass of each atom? Mass of each atom, which you have already studied in class 11th, is equal to what? Molar mass divided by Avogadro number. Now, molar mass means if it is an element, you will take what? Atomic mass. So, we will write this m divided by Na. Okay. So, what will be the mass of the unit cell? Mass of the unit cell is equal to number of atoms per unit cell is Z, and mass of each atom is equal to what? Molar mass divided by Avogadro number. So, this is mass of the unit cell. Then density of the unit cell is what? Mass of the unit cell divided by volume of the unit cell. So, density is equal to mass of the unit cell, what will you write? Z into m divided by Na, and what is the volume of the unit cell? A cube. So, the unit will be grams per cc, because molar mass is what? Gram per mole. So, by using this equation we can calculate what? Density. Z represents what? Number of atoms per unit cell. M, just be particular, this m represents either the molar mass or atomic mass. Na is Avogadro number and A represents what? Edge length. So, is it clear? That is, how will you calculate the density of a unit cell? We can find out the edge length by X-ray diffraction, then we can find out the number of atoms per unit cell if you know the type of lattice. If both these are known and if you know the atomic mass, then you can calculate what? Density. So, edge length we are taking it as A centimeter, then volume of the unit cell will be equal to what? A cube centimeter cube, then density of the unit cell is equal to what? Mass of the unit cell divided by volume of the unit cell. Now, mass of the unit cell is equal to what? Number of atoms per unit cell into mass of each atom, and mass of each atom is what? Molar mass divided by Avogadro number. So, finally, mass of a unit cell is equal to Z into m divided by Avogadro number, or you get density is equal to Z into m divided by Na into A cube. Z is number of atoms per unit cell, m is the molar mass or atomic mass, Na is Avogadro number, A represents what? Edge length. So, using this we will do some numericals. Now, this question is, see, niobium crystallizes in a BCC structure having cell edge of 143 picometer. Calculate the density of niobium. Atomic mass of niobium is given as 93 gram per mole. Now, so you have to calculate the density. So, what is the in first line what is given? See, niobium crystallizes in a BCC structure. BCC structure means number of atoms per unit cell is how much? 2. So, you can write Z is equal to 2, it is given to you. Then edge length is given, having cell edge of 143 picometer. So, A is equal to 143 picometer. We will convert it into centimeter. Why? Because mass is in gram per mole. So, 143 into 10 to the power of minus 10 centimeter. Edge length is given to you. Then Avogadro number, you know it, 6.022 into 10 to the power of 23 mole inverse. Then atomic mass is given, m is equal to how much? 93 gram per mole. Then what is the equation for density? D is equal to Z into m divided by Avogadro number into A cube. So how much it will come? 2 into 143, sorry, 93 divided by 6.022 into 10 to the power of 23 into 143 into 10 to the power of minus 10 the whole cube. See here the calculations are very lengthy. So you have to do it fast because now you can't use calculator, even log tables are also not allowed. So you have to do it manually only. So when you calculate it, it comes to be 105.1 grams per cc. So this is how you will get the density. Is it clear? Niobium crystallizes in a BCC structure having cell edge of 143 picometer. Calculate the density of niobium. Atomic mass of niobium is given. So since niobium is having BCC structure, the number of atoms per unit cell is how much? 2. So Z represents what number of atoms per unit cell. Then edge length is given 143 picometer. So 143 into 10 to the power of minus 10 centimeter. Avogadro number 6.022 into 10 to the power of 23. Atomic mass is given. So 93 gram per mole. And the formula you have to use is D is equal to Z into m divided by Na into A cube. And when you do the calculation, it comes approximately to be 105.1 grams per cc. See, in this chapter the numericals are very easy. There is only one formula and direct you have to just substitute the values given in the equation. So is it clear? Next question is the density of a face centered cubic element atomic mass 60.2 gram per mole is 6.25 grams per cc. Calculate the edge length of the unit cell. So the density of a face centered cubic element atomic mass 60.2 gram per mole is 6.25 grams per cc. So density is given, D is equal to 6.25 grams per cc, and it is having what type of lattice? FCC. So Z is equal to 4. Then what is given? Atomic mass is given 60.2 gram per mole. And what is asked here? Edge length. The equation is the same only. D is equal to Z into m divided by A cube into Avogadro number. So what will be A cube equal to? A cube is equal to Z into m divided by D into Avogadro number. What will be A? A will be cube root of Z into m divided by D into Avogadro number. So the value comes to be how much? A is equal to cube root of, what is Z? 4 into atomic mass is 60.2 divided by density is how much? 6.25 into 6.022 into 10 to the power of 23. So when you calculate, it comes to be 4 into 10 to the power of minus 8 centimeter. So this is the value, approximately 4 into 10 to the power of minus 8 centimeter. So is it clear? The density of a face centered cubic element atomic mass 60.2 gram per mole is 6.25 grams per cc. Calculate the edge length of the unit cell. Density is given how much? 6.25 grams per cc. Then FCC lattice, so Z is equal to 4. Molar mass is given 60.2 gram per mole, and you have to calculate what the edge length. So the equation is the same. D is equal to Z into m by A cube into Avogadro number. A cube is equal to Z into m divided by D into Na. So A is cube root of this. So when you calculate the value, it comes to be 4 into 10 to the power of minus 8 centimeter. Now see how what I have written here, equation to calculate number of unit cells when 1 volume of the element is given and 2 volume of the unit cell is given. So directly you can use it this way, number of unit cell is equal to volume of the element divided by the volume of the unit cell. And what is the volume of the element? What is density of element? Density of element is equal to mass of element divided by volume of element. Okay. So instead of volume of element, we can write it as what? Mass of element divided by density of the element. Okay. That is, number of unit cell is equal to volume of the element divided by volume of the unit cell. Then density of the element is equal to what? Mass of element divided by volume of the element. So, volume of element is equal to what? Mass of element divided by density of the element. So, the same equation becomes what? Number of unit cell is equal to mass of element, that should be in grams, divided by density of element into volume of the unit cell, volume of unit cell. So, here you see mass of the element, that is number of unit cell is equal to mass of the element in grams divided by density of element into volume of the unit cell, or I can write it as W grams divide of what? It will come element divided by density of element into volume of, instead of volume of unit cell you can use this also, no, AQ. So, the same equation you can use, number of unit cell is equal to mass of the element, it is not molar mass or atomic mass, it is the mass of the element divided by density of elements into A cube. Same way you can calculate number of atoms also. Number of atoms in a unit cell is equal to what? Z into volume of element divided by volume of unit cell. Okay. So, the same equation can be modified, number of atoms is equal to Z into mass of element divided by density of element into volume of unit cell. I can write number of atoms is equal to Z into mass of the element in grams divided by density of element into volume of unit cell. So, using this equation you can calculate directly the number of atoms. Otherwise, you see, using this equation D is equal to Z into M divided by Avogadro number into A cube. You can calculate the number of atoms also. For that, first you have to calculate what? Atomic mass or molar mass, and then you have to calculate what? Number of atoms. So, if you use this equation directly, number of atoms Z into mass of the element divided by density of the element into volume of the unit cell, also you will get the answer. It is direct substitution only, it is very simple. Otherwise, first you have to calculate what? The molar mass or atomic mass, and then you have to calculate what? Number of atoms. So, it is very easy, this is easy. But the thing is that you have to read the question properly. What should be given? The mass of the element should be given. It is not, do not get confused with what? Atomic mass or molar mass. Is it clear? I will give you say a question related to this. So, understood? Number of unit cell is equal to volume of the element divided by volume of the unit cell. So, instead of giving the volume, sometimes they may give you the mass of the element. In that case, you will use mass of the element divided by density into volume of the unit cell. Using the same equation, you can calculate number of atoms also. For that, you have to introduce which factor? Z. So, number of atoms is equal to Z into mass of the element divided by density of the element into volume of the unit cell. If you want, you can calculate number of atoms using this equation also. For that, first you have to calculate what? Atomic mass or molar mass, and then you have to calculate number of atoms. So, if you use directly this one, it is very simple. But the thing is that you have to read the question properly and you have to see what is given to you, whether it is atomic mass or molar mass or mass of the element. So, let us try a numerical related to see the question. An element has BCC structure with cell edge of 288 picometer. Density of the element is 7.2 grams per cc. How many atoms are present in 208 gram of the element? So, here what is given? You have to calculate the number of atoms in 208 gram of the element. Does the 208 gram represent the atomic mass or molar mass? It is not the molar mass, it is what? The mass of the element. Okay. So, it is having BCC structure, Z is equal to 2, then its edge length is given how much? 288 picometer. So, it is how much? 288 into 10 to the power of minus 10 centimeter. Then next what is given? Density is given 7.2 grams per cc. and mass of the element is given in grams, 208 gram. Then what is asked? You have to calculate the number of atoms. Now, if you want to use this equation, D is equal to Z into M divided by Avogadro number into A cube. You can use this equation. For that, first you have to calculate what? Atomic mass. Then you will calculate what number of atoms using both atomic mass and mass in grams is also given to you. So, instead of using this equation, directly you can use this equation what I gave you now. It is simple. Number of atoms, the answer will be the same, Z into mass of the element in grams divided by what? Density of the element into what will come? A cube. So, how much it is coming? 2 into 208 divided by density of the element is 7.2 into A cube is how much? 288 into 10 to the power of minus 10, the whole cube. So, the answer comes to be 2.42 into 10 to the power of 24 atoms. It is simple to do. Otherwise, first you have to find out the atomic mass, then number of atoms is equal to mass in grams divided by atomic mass into Avogadro number. So, that equation you have to use, or number of atoms is equal to what? Number of moles into Avogadro number. So, instead of using that, you can do it this way directly, the answer will remain the same. An element has a BCC structure with cell edge of 288 picometer. Density of the element is 7.2 grams per cc. How many atoms are present in 208 gram of the element? So, Z is 2, edge length is 288 into 10 to the power of minus 10 centimeter. Density is equal to 7.2 grams per cc and mass of the element is 208 gram. So, number of atoms is equal to Z into mass of the element divided by density into A cube, and when you calculate you will get it as what? 2.42 into 10 to the power of 24 atoms. Or if you use this equation, D is equal to Z into M divided by A cube into Avogadro number. First you will calculate what? Atomic mass. After calculating M, then number of atoms is equal to what? Number of moles into Avogadro number. So, number of moles is equal to what? Mass divided by atomic mass into Avogadro number. So, that way also you can calculate. So, if you do it this way or you do it this way, it is the same. This is more simple for doing. So, is it clear? So, only this type of numericals are there. So, with this portion is over. So, in the next class, we will be discussing about defects in crystal, how defects can be brought in a crystal.